distributions. So histograms can take on any of several common shapes. Okay, among these distributions are, so if we take a look and our histogram is symmetrical, that means that on the right side and the left side, there is a mirror image. We can get the normal distribution, the bimodal distribution, or the uniform distribution. I'll draw that here under uniform. Okay, or if we see a skewed, so just not a symmetrical distribution, it's either left skewed or right skewed. So right skewed is when the tail is really skinny to the right, and left skewed is when the tail is really skinny to the left. Okay, the next couple slides, you can go ahead and define these. I drew them for you, so let's take a look. Okay, first let's draw the normal distribution. This is the bell curve. Okay, it goes up, it goes down, and it's symmetrical. Bimodal is when we have two peaks. Okay, so bimodal, if you listen to the name mode, okay, there's two modes. Okay, so this is a mode, and this is also a mode. Okay, for the normal, the mean, median, mode, mean, median, and mode are all the same value. Okay, right skewed, again, that's when the tail is skinny on the right hand side, and left skewed, the tail is skinny on the left. Okay, normal distributions. Normal distributions are commonly referred to as bell curves. The middle intervals will have the greatest frequency, so like the tallest bar. So what this would look like as a bar graph is it would have bars going like this. Okay, with the greatest frequency right in the middle here. All other intervals have decreasing frequencies as you move away from the center of the graph. Okay, so smaller and smaller and smaller toward the left, and then smaller and smaller and smaller toward the right. Okay, i.e. the bars get smaller as you move out to the edges. Let's go ahead and do a question with normal distributions. So a pair of dice were rolled 75 times, and after each roll, their sum is recorded, and then those frequencies were graphed. Okay, so if we take a look at this, even though this isn't a perfectly symmetric, okay, we can see that this number and this number are not exactly the same, or this one and this one, right? It still fits the definition of a normal distribution. Okay, highest in the middle, which we can see right here, it's around the 7, and then it gets smaller and smaller toward the edges, and it's approximately the symmetrical. Now, bimodal distributions, these look like inverted normal distributions. The intervals with the highest frequency or the tallest bars are at both ends of the graph. So it may look like this and then go back down. Okay, the highest ones are at each end. And there could be more bars here, that'd be fine, but the tallest bars are definitely not together. Okay, the lowest frequency is in the center. So here's the lowest frequency. Lowest. Okay, frequencies increase as you move away from the center of the graph. So toward the left or the right. Okay, so an example, a class of grade 6 and grade 1 students each measured their heights. They recorded and graphed them. Okay, if you think about it, the heights of most grade 1s are going to be, like maybe the mode's going to be the same, around the same, which is from 110.5 to 111.5. But then no one's really going to be in the middle. And then all of a sudden grade 6 is much taller, 155.5 to 160.5. Okay, so we have two separate and different peaks. And that can be a result of the age difference. distributions, this is when the frequencies in each interval are either equal or approximately equal. Okay? A die is rolled 50 times and the face is recorded in graph. So this is what the die faced up, either 1, 2, 3, 4, 5, or 6. And if we actually take a look, they're all approximately around the same height, the same level here. Okay? That's uniform distribution. Okay, and there are two kinds of skewed graphs. So there's right skewed, which is a positive skew, when the bars with the highest frequency are on the left, and the frequencies decrease as you move right. And then an example of that, we'll do an example first. An example of that is household incomes in the United States. Okay, if you think about it, household incomes are all going to be clustered. A lot of people make around the same money. Maybe let's just say between $30,000 and $60,000. That's like the most popular. There are some people that make less than that, maybe even $0, but there are very few people that make more and more and more and more of that money. So maybe like $1 million a year. Okay, and it stops at 0. You can't make less than $0. Okay, or housing prices. Okay, houses are all around the same prices. You don't have many that are below, and you only have a couple that are, or very few when compared to the cluster or the average, are higher. Number of children in a family, again, we can't have less than 0. And if you think about it, most people have 2 or 3. Some people have 1, some people have 0, and then very few are, it's skewed right because very few have like 5, 6, 7, 8 kids. Okay, now skewed left. This is when the bars, the highest frequency, are on the right side of the graph. Okay, an example of this is number of fingers. If you think about it, most of us have 10 fingers, but some people could have lost 1 or 2, and that's where that left skew comes into place. Or scores on easy tests. Well, if the test is so easy, most of us are going to score very, very high on it, but then there's going to be like people that overlook a question and maybe don't read it very well, and that's where that left skew comes into place. And then age of death as well. Okay, and just to point this out, the median in a right skewed is just off the center, and the average is to the right of the median. Because these outliers here on that right skew are going to pull up the average from like the peak. Okay, and left skewed, the same thing. The mean is going to be even below the median, and the values, the data values in the left skew are going to pull that mean down.